Good day, my dear student. Welcome back to our General Mathematics lecture series number 3. Again, last time we discussed the different concepts, especially the introduction of functions. We defined the function and relation. We even discussed the concept of vertical line test. And after that, we had the lecture series number 2. We discussed the evaluation of the functions. Once again, I'm Agi Padiaos, your teacher in General Mathematics in Gisad Valley National High School, Senior High Department. So our focus today is the operation of functions. To start with the operation, of course, the very number one that we're going to start with is the addition of functions. So let's try to have. In the addition of functions, we will understand this one if we are going to have the illustration immediately. So how do we add two functions, three functions, or more than two functions? Let's say, for example, we have in here two functions, function f of x and function g of x. So it says in here we're going to get the sum. So when we are going to get the sum, there are things that we need to understand. Okay, the domain of the function. Now, last time we discussed the domain of the function. We have said that generally the domain of the functions are all real numbers except when the given function dictates some certain limitation. But in our example, we do not have a limitation. So the domain of this function involved in our operations are all real numbers. Okay, they're all real numbers. So we have in here the addition of the function. When we are going to add two functions, we have to remember this notation. So it says in here, f function plus g function. So what would be the result? It will give you a result of f of x plus g of x. Meaning, the definition of f of x must be added with the definition of g of x. Now, what is the definition of f of x? F of x is defined as 9x minus 3. Okay? 9x minus 3. And it will be added to the definition of g of x, which is we have in here 6x plus 1. Okay, so as you can see, we have now in here an illustration to add the two functions involved. Okay, to add the two functions involved, you are going to add the definition of this f of x. What is the definition we have in here? 9x minus 3 added with definition of g of x, which is we have in here 6x plus 1. And so we have in here. Now, how are we going to add? Okay, how are we going to add? Again, go back to the rule of law of signed number. You combine the like terms. So what are the like terms in here? We have the 9x and 6x. Combine them to give you 15x. Now another one in here is negative 3 and positive 1 we are going to add. So that is the addition of unlike signs. So when we are going to add the unlike signs, we just subtract and carry the sign of a greater number. So as you can see in here, negative 3 plus 1, it will give you 2. What is the sign of the greater number? That is negative, and so we have in here negative 2. Final answer, the final answer would be 15x minus 2. Next, you will notice that if the domain of the two functions involved in here are all real numbers, it will follow that the result will have a domain of all real numbers. Okay. Another one in here is subtraction. Now, how are we going to subtract two or more functions? Consider this notation again. Now, what is the notation? You will notice in here that the notations we have is f function minus g function. Now, what would be the result? The result would be f of x minus g of x. This one, this notation in here will be your guide to subtract. So you try to consider the definition of f of x as your main wind. Okay, so ayan. We have in here the definition of f of x, which is the quantity 9x minus 3. Okay, we have in here the symbol for subtraction, and that is minus. Now, what is the definition of g of x? We have the quantity g, the quantity 6x plus 3. Now we're going to subtract. When we are going to subtract, of course, we will remove the enclosure symbol. So if a binomial is a positive binomial, immediately you can remove the enclosure symbol. Like, for example, this one, the quantity 9x minus 3. You can just say 9x minus 3. Now, what about if the binomial is negative? Of course, you distribute this negative symbol. So we have in here negative multiplied by 6x, it will give you negative 6x. Negative multiplied by positive, it will give you negative. And so negative multiplied by positive 1, it will give you negative 1. And after having now this one, this removing of the symbol or removing of the enclosure symbol, you proceed now to the indicated, you proceed now with the indicated operation. So you will notice in here 9x minus 6x, it will give you positive 3. We have in here negative 3 and negative 1. That is combine the number, which is 4, or shall we say negative 4. So the result would be 3x minus 4. So again, the domain of this result will all be real numbers. Another illustration. So we have in here. So we have in here the illustration. The f of x is defined by the expression the quantity x minus 3 raised to the second power, and the g of x is defined by the expression x minus 1. So you will notice the question in here is that what are the domain of these two functions? Again, there is no such limitation, so the domain of these two functions, f of x and g of x, are all real numbers. Yeah. So after knowing the domain, we can now go to the operation, shall we say the addition. Again, in the addition of the functions, we need to consider again this notation. Function f plus function g will give you a result of f of x plus g of x. So this will always be your pattern when you're going to add the two functions. For f of x, we have in here the definition of f of x, the square of the difference of x minus 3, plus the definition of your g of x, which is x minus 1. Now, how are you going to add the two functions in here? Of course, if one of your addends is in the second power, or shall we say the square of the quantity x minus 3 raised to the second power, or the square of x minus 3, what are you going to do? You expand. So how do you expand? Let's try to have the shortcut of expanding the number. So x raised to the second power. So ayan, x raised to the second power. So we have x raised to 2. Now x multiplied by 3, it will give you negative 3x multiplied by the constant 2. So it will give you negative 6x. Of course, this one, negative 3 raised to the second power, it will give you a result of positive. Now, as what we have said last time, that when the expression is a positive, you can just remove the enclosure symbol, so it will give you x minus 1. So the symbol for the addition we have in here, plus. So to proceed in answering this problem, combine the similar terms. So x raised to 2 do not have any companion, so you just copy, so it will give you x raised to 2. Now what about this one? Negative 6x, okay, and x. So how are you going to do that one? You just subtract, and so it will give you negative 5x. How about this one? Positive 9 minus 1. It will give you positive 8. So the final result will be x raised to 2 minus 5x plus 8. So that is how to add functions. So again, it will follow that the domain of the functions when combined are all real numbers. Now, how about the subtraction? Again, in the subtraction, we need to consider these notations. And we have in here, function f minus function g will give you a result of f of x minus g of x. Uh, again, to subtract two functions, we need again to consider these function notations. So we have in here f of x minus g of x, meaning if we have this one, we just subtract its definition. Now what is the definition of your f of x? I'll go back to the problem. So the square of the difference of x and 3. And what about the g of x? That is the difference of x and 1. Now how are we going to subtract them? We will follow this notation. So let's try to have. So you will notice in here, what is the definition of this f of x? We have the quantity x minus 3 raised to the second power minus, as you can see in here, the definition of g of x. What is the definition of g of x? We have the quantity x minus 1. Now to subtract the problem, again expand the square of binomial x minus 3. Now what is the expanded form? We have already expanded that one. So what is the result? The result will give you x raised to 2 minus 6x plus 9 minus x plus 1. You will notice this x raised to 2 minus 6x plus 9 is the expanded form of our of the square of binomial x minus 3 raised to 2. And of course, this minus x plus 1 would be the result of negative multiplied by x. It will give you negative x. Negative multiplied by negative 1, it will give you positive 1. So what is the final answer? The final answer would be the combination of similar terms. So is there a companion of x raised to 2? There is none, so we just copy x raised to 2. How about 6, negative 6x and negative x? We combine them, so it will give you negative 7x. And of course, positive 9 and positive 1, it will give you positive 10. So what is the final result or the difference of these two functions? The difference is that x raised to 2 minus 7x plus 10. Now, of course, again, the domain of that one will be all real numbers. All real numbers. So what about when we consider multiplication of functions? Now, when we are going to multiply two functions, we have to consider this notation. Function f multiplied by function g will give you a result of f of x. And so we have in here f of x multiplied by g of x, or the product of f of x and g of x. So this one is the pattern when we are going to multiply the two functions. So we have in here, as you can see, the definition of f of x is the same as x minus 3 multiplied by the definition of g of x, which is x plus 1. So as you can see, to get the product, multiply the two binomial, and so x multiplied by x, it will give you x raised to 2. X multiplied by positive 1, it will give you positive x. Negative 3 multiplied by x, it will give you negative 3x. And negative 3 multiplied by 1, it will give you negative 3. Now, what is the final result? The final result would be the combination of similar terms. If there is no similar term, just copy the terms. So, as you can see, there is no companion for x raised to 2, so we just copy it as x raised to 2. Now, what about your x and negative 3x? That is subtraction of similar terms, so it will give you negative 2x. Now, what about the what about the 3? Is there a companion for 3? There is none, so it will give you negative 3. What is the final result? X raised to 2 minus 2x minus 3. Now, what would be the domain? Again, the domain is all real numbers. Now, what about when we are talking of division of functions? The division of function would be the quotient of the two functions. So consider these notations that we have. So what are the notations that we have? We have in here the quotient of f and g of x will give you a ratio of f of x over g of x. So this f of x over g of x is our pattern when we are going to divide the two functions involved. So let's continue. You will notice we have in here x minus 3 over x plus 3. So as you can see, f of x, the definition is x minus 3, and g of x, the definition is x minus 1. Now, the result is already in its simplified form, so that would be the final result. Now, what would be the domain of the function? Of course, the domain of this function, the result, the domain of the result of these two functions is, of course, all real number, but we need to disregard negative 1, because when we considered negative 1 to be the value of x, it will give you a denominator to be 0, and there is no rational function to speak if the denominator is 0, because the number is considered to be undefined. So it says in here, all real number except negative 1. Those are the domain of the function. Now, what about if we consider this next problem? The product of f of x, which is x minus 5 raised to 2, and g of x, which is x minus 2. Now, what would be the product? Again, consider this notation. Our notation in here is that the product of f function and g function is equivalent to f of x multiplied by g of x. So we just follow this given pattern that we have. So what is the definition of f of x? We have in here the square of x minus 5 multiplied by the definition of g of x, which is x minus 2. Now, how are we going to get the result? Of course, we need to expand the square of x and 5, which will give you a result of x raised to 2 and x raised to 2 minus 10x minus 25 multiplied by our original multiplicand, the quantity x minus 2. So what would be the result? That is, it will give you x raised to 3 minus 12x raised to 2 plus 45x minus 50. This would be the product. How did I arrive with this one? I made use of the distribution method. Okay, so again, our result is a cubic function, and so the domain are all real numbers without restriction. Now, what about if we are talking of the division? So again, consider this notation for the division. Now, what is the notation for the division? That is the ratio or quotient of f of x over g of x. And again, this is the pattern. How are we going to divide? Divide the definition of f of x divided by the definition of g of x. Consider this one. Okay. So we have in here, what is the definition of f of x? It is the square of x minus 5 raised to the second power over the definition of g of x, which is x minus 2. You will notice again that the functions or the rational functions we have in here is in its simplified form. Okay, so that is already the final result. Now, what is the domain of the quotient that we derive? Of course, all real number except positive 2. Why except positive 2? Because when we consider positive 2 as the value of x, now it will give you a denominator of 0. And so if we have a denominator of 0, the number will be considered to be undefined number. Okay. The next thing that we are going to discuss is the composition of the function or composite function. Now you will notice that when we are talking of composition of function, there are at least two functions involved, or shall we say two or more functions involved. Now, to understand this, consider this illustration. Okay, so you will notice in our illustration, the first stage is that the illustration of the first input. We know the fact that in the first function that we have in here, our input is x, meaning to say, after computing this first function, the result, or shall we say the output of the first function, will be considered now to be the input of the next function. So you'll notice in here, the function g of x has an input of f of x. So, so if we are going to make use the f of x to be the input of the g of x, we will be having a result or another output which is the same as g of f of x. So that is the reading. So again, the reading of this last output in here is g of f of x. So that is how the composition of functions work. Okay, so let's move on. We have in here the example. So there are two functions involved. So we have in here f of x is defined by 2x raised to 2 plus 8. Now another function is g of x is defined by x minus 3. Now, to get the composition of the two function, there is the value of the x given. So that is 3. So we have in here the composition of g function and f function of x. Now how do we compute for this one? So try to see or try to look at the figure, or shall we say the pattern we will be having in here. So we have the pattern in here which is g of f of 3. Now you will notice this g of f of 3 is the same as in our last output in the illustration. Now, how are we going to answer this one? Let's try to continue. So you will notice when I'm going to evaluate this pattern, or shall we say composition of the function, I will first evaluate the f function, which is I have in here f of 3. I will replace the x with 3 and continue solving the equation according to its definition. 2 multiplied by 3 raised to the second power plus 8. So you will notice this pattern is the same as the definition of this f of x. Now let's continue. Now f of 3 will give you a result of 26. Why? 3 raised to the second power is 9, multiplied by 2 is 18, plus 8 will give you 26. Now this 26 is the output of the f of x. Now this 26 will already be used as an input of the next function g of x. So we have in here. So let's continue. Now in your g of x, it will give you now g of 26 is equal to 26 minus 3. Now how is this 26 minus 3? This 26 minus 3 is actually this one, the second function g of x, which is x minus 3. We just replace the x in here using the result, which is 26. So g of x is equal to 26 minus 3 will give you 23. And so that is the result of the composition of the function. Consider again this one. What about if we are going to have the composition of g function and f function if the value of our x is negative 2? How do we solve for this one? Let's try to consider the given illustration. Now, the pattern we have in here, or the illustration we have in here, is g of f of negative 2. How do we solve for this one? Again, solve for the first uh, input, or the first function, f of x. So consider the f of x, which is 2x raised to 2 plus 8. Now replace the x with negative 2. So we have in here f of negative 2 will give you 2 multiplied by negative 2 raised to the second power plus 8. Now what would be the result? Now we have in here f of negative 2 will give you a result of 16. Why 16? Negative 2 multiplied by negative 2, it will give you 4. Multiplied by 2, it will give you 8. Plus 8, it will give you 16. So that is the result of the first function. The result of the first function will be given as the input of the second function. So you notice in here the g of x is equal to x minus 3 will already be evaluated by 16. So g of 16 is equal to 16 minus 3. And what would be the result? G of 16 will give you a result of 13. And so that is how to evaluate this uh, second set of composition or composite function. Another one in here is, what about if we are going to interchange? Let's say, for example, the number one, the first illustration in here. So as you can see, they have the same values of x. Okay, so the composition of f function and g function, if our x is 3, will give you this pattern again or result, f of g of 3. So what are you going to do? Do first the g of 3, which is the same as we have in here. G of 3 is defined by, g of x is defined by x minus 3. And so when we are going to evaluate, we have in here the 3, we make use of 3. So we have g of 3 is equal to 3 minus 3. Of course, it will give you a result of 0. So the g of x is equal to x minus 3 when x is 3 will give you a result of 0. Now, how about the second function? Okay, to compute for the second function, we make use of that result 0 to be our input for the second function. So, compute for the second function. What is our second function will be? The second function will already be f of x raised to no. The second function is f of x is equal to 2x raised to 2 plus 8. So make use of the 0 to evaluate this function. So we have now f of 0 is equal to 2 multiplied by 0 raised to 2 plus 8. What would be the result? Of course, that is the same as 8. So again, we have in here a problem. The composition of g function and f function if the value of our x is a. How do we compute for that one? Again, we make use of this pattern. So g of f of a. So to solve for it, compute the first function, which is f of x is equal to 2x raised to 2 plus 8. So we have in here f of a is equal to 2a raised to 2 plus 8. That would already be the result. Why? Because our number is considered to be a variable. Okay. So again, what about the second function? G of x is equal to x minus 3. Of course, when we evaluate this one, make use of this result, 2a raised to 2 plus 8 as our x in the second function, or as our input in the second function. So you will notice in here, we replace the x, which is in here, x, which is 2a raised to 2 plus 8. Of course, minus the original subtrahend, that is 3. So we have the final result, that is 2a raised to 2 plus 5. Now, what about if we are going to interchange the function? Now, what would be the result of f function and g function if our x would be just the same a? So to solve for it, again, follow this pattern. What is the pattern? F of g of a. So to solve for the problem, of course, we will solve first the g function as our first function to be computed. So we have in here now g of a is equal to a minus 3. We just replace the value of x. What is the value of x? A. So g of a is equal to a minus 3. That would already be the final result, because our number for, or the value of x is a variable a. Now to solve for the second function, we make use of the result of g function, which is a minus 3. So to solve for it, f of a minus 3 will give you a result of 2 multiplied by the square of a minus 3 plus 8. Of course, to solve for this, expand first the binomial, the square of binomial. So when we are going to expand, we have in here now the result. 2 multiplied by a raised to 2 minus 6a plus 9. That is the expanded form of a minus 3 raised to the second power. Of course, multiplied with its original multiplicand, that is 2. So 2 multiplied by the quantity a raised to 2 minus 6a plus 9 and plus 8. Now what would be the result? That is 2a raised to 2, 12a plus 26. Where did this 26 came from? That is uh, 2 multiplied by 9, it will give you 18, plus 8, it will give you 26. So again, thank you for your patient in understanding our lesson, and of course our module which was given to you ahead of time. Before you go out, please subscribe and click the notification bell so that you will be reminded of the new lessons posted. Again, if you have any queries, just type in the comment box in your page, the course subject General Mathematics. Do not forget to have your attendance below the description. Just click the link and fill in your attendance. Thank you so much for lending me your ears.